Hi, you're a meat tube with opinions, shoveling things into your body and... Wait, what the heck is going on here? So, what exactly is nutrition? It's your body extracting nutrients from food and using them. And what are nutrients? The stuff your body can't make itself, molecular building blocks. Okay, before we talk about what these nutrients actually do inside, you need to meet the machines running your food factory. First up is your mouth, your built-in grinder. You're chopping food into paste, while salivary enzymes start the very first round of digestion. And P.S., if you don't chew properly, your stomach absolutely hates you. And once the grinding is done, then it enters the stomach, your personal acid tank. This is where proteins unfold, invaders get wiped out, and everything turns into usable mush. Basically, demolition phase completed. And once demolition is done, that mush slides into the small intestine. Inside the small intestine, the pancreas releases biochemical scissors that cut carbs, fats, and proteins into tiny absorbable pieces. And then, welcome to the absorption zone, the long, winding pipe where nutrients actually enter your body. This works only because the walls are covered with villi and microvilli, your microscopic absorption carpet that multiplies surface area hundreds of times. Just like the tiny loops on a towel help it soak up more water, and whatever it does get absorbed goes straight to the boss, the liver, the command center for nutrients. Every molecule reports here before entering your bloodstream, and the liver decides whether to burn it, store it, detox it, or send it elsewhere. Moral of the story, you're not what you eat, you're what you absorb. Alright, factory tour over. Now let's look at the inputs, the macronutrients. These are your three big boys: carbs, fats, and proteins. Stuff your body needs in large quantities. Unlike micronutrients, vitamins and minerals, which you only need in tiny amounts. But we'll get to those later. Carbohydrates first. They are your body's preferred fuel. Every type of carb you eat gets converted into the same molecule, glucose. Once that glucose shows up, your body has two options: immediate energy or glycogen storage. Your liver and muscles stash a little for later, but glycogen tanks are tiny. Once they're full, any extra glucose gets converted straight into body fat. So if every carb turns into glucose, then why the differentiation? It's all about how they're built and how fast that glucose enters your bloodstream. Simple carbs are tiny chains. Your body digests instantly. Fast blood sugar spike, fast crash, fast hunger. Whereas complex carbs are long, tangled chains. Slow digestion, slow glucose release, smooth energy, keeps you full for long. And then there's fiber, a carb your body can't digest, but your gut bacteria munch on it to keep your gut healthy and level up your poopy game. Fiber also slows down glucose absorption, which helps prevent blood sugar spikes. Now, fats. Your brain is 60% fat. Your cell membranes are made of fat. Your hormones depend on fat. So fat is definitely not an enemy. And what makes a fat healthy or harmful is its molecular structure that determines how your body uses it. Saturated fats, like butter and coconut oil, are solid at room temperature and chemically stable, which is why they tolerate heat well. Good for cooking, fine in moderation. Monounsaturated fats, like olive oil, are liquid but still stable, the gold standard for everyday fats and heart health. Polyunsaturated fats include omega-3s and omega-6s. Their multiple double bonds make them liquid and fragile, so they oxidize easily under high heat or heavy processing. And it's the main reason seed oils are debated. But your body needs both. Omega-3 helps reduce inflammation. Omega-6 helps create inflammation for healing. It's the ratio that matters. Artificial trans fats, on the other hand, are harmful because of their unnatural structure. They're created by hydrogenating oils, which forces the fat into a rigid shape your body struggles to process, and messes with your body in multiple ways. Avoid completely. And finally, fat isn't the enemy. It's the transport system your body uses to absorb key nutrients like vitamins A, D, E, and K. Now protein. Its reputation speaks for itself. Every cell in your body is made of protein, but unlike carbs and fats, your body has no storage tank for it if you don't eat enough. Your body steals it from your muscles, hair, and nails just to keep your heart beating. Protein is built from 20 Lego bricks called amino acids. 9 are essential, meaning your body can't make them. The other 11 are non-essential. Your body can manufacture them. The trap is this: if you're missing even one of the 9 essential amino acids, the entire construction project stops. That's why animal protein, which is complete, is biologically easier for your body to use compared to many plant proteins. This is where variety matters, like how legumes such as peas are typically low in methionine, while grains tend to be low in lysine, so combining them fills those gaps. Now for muscle building. To flip on muscle protein synthesis, the body's build switch, you need a specific amino acid called leucine. Muscle growth works like an on-off switch. You only turn it on when you get enough leucine in a single meal. For most people, that usually means getting around 30 grams of quality protein at once. Smaller amounts throughout the day often aren't enough to activate the switch. Protein also has a higher thermic effect. Your body spends more energy digesting it, which means you burn a few extra calories in the process. Now, about quantity. The RDA is basically the don't die minimum, the amount needed to prevent deficiency. For different people, it looks more like this. The food you eat doesn't become energy instantly. Carbs and fats enter your bloodstream as raw materials. They have to be delivered into the mitochondria. Yes, the powerhouse of the cell. Inside the mitochondria, these raw materials are converted into ATP. Think of it as the currency your body spends to move, think, and stay alive. But mitochondria need micronutrients to act as cofactors, so they can turn carbs and fats into usable energy. Now, a healthy metabolism behaves like a hybrid engine. It has two main fuel systems, glucose and fat, and it can switch between them depending on what's available. Sugar mode. When you eat, blood sugar rises. Because high sugar is damaging, your body prioritizes burning this first. Fat mode. Once the sugar's gone, it flips a switch and starts burning stored body fat. This is metabolic flexibility, and it's a sign of a healthy engine. If you snack all day, you constantly refill the glucose tank, and your body never gets the chance to switch into fat-burning mode. And then there are the non-caloric nutrients. They do not provide energy, ATP. You could eat 10 pounds of salt and drink 50 gallons of water, and you would technically have consumed 0 calories. So why do we need them? Because they basically ignite the energy to happen. We divide these into two. Water, the forgotten macro. Vitamins and minerals, the micros. Okay, water. You already know the deal. Hydrate, human. Alright, vitamins. They come in two types, and the difference is simple. How long your body keeps them. First, the fat-soluble vitamins. A, D, E, and K. Think of these as long-term renters. They stick around into liver and body fat for weeks or months and handle different jobs. Since they stay for a while, your body can use the stored ones, but without bringing in new supply for too long. Boom. Deficiencies. Oh, and they only absorb properly with some fat in the meal. Then the water-soluble vitamins, B complex and C. These are the tourists. They come in, do their job, and whatever isn't used leaves your body through P, because most of them don't stay. You need to refuel regularly. Finally, minerals. These are raw elements from the earth, grouped here by their main job. First, the electricians. They control electrical signals and fluid balance, the stuff that keeps muscles contracting and nerves talking. Second, the builders. This is the material your body uses to build and maintain bones and teeth. And third, the catalysts. These are like your body's specialized tools. Iron carries oxygen in the blood, iodine fuels thyroid hormones, and zinc triggers reactions that help cells grow and heal. Now, where does all this actually get processed? The gut. It's a long tube running from your mouth to butt. It is often called your second brain because it contains millions of neurons and constantly chats with your actual brain. It influences your mood, cravings, and even immune system. Inside this tube lives the microbiome, trillions of microorganisms, both good and bad. The goal is to maximize the good ones through environment and food, especially fermented foods. These contain probiotics, live beneficial bacteria. You feed them prebiotics, a type of fiber. In exchange, they ferment that fiber and make SCFAs. These SCFAs lower inflammation and keep colon cells alive. These bacteria live on the mucus layer, a literal physical barrier that protects your intestinal wall. But if you starve the good bacteria or constantly irritate the gut with stress or processed food, that mucus layer thins out. This is leaky gut. Bacteria and toxins escape the tube and leak into your bloodstream, and your immune system goes to war. A bad gut can also trigger cellular breakdown, which happens in 3 distinct ways. First is inflammation, the fire. Acute inflammation is the first responder. It heals a cut or repairs a muscle. But chronic inflammation is a wildfire that never goes out, slowly burning down healthy tissue. It's itself a huge topic. Let me know in the comments if you need a full breakdown on this. Second is oxidation, the rust. Just like a car produces exhaust, your cells produce free radicals. Without enough antioxidants to filter them, your cells literally rust. This is what damages DNA. But don't fall for internet drama. You don't need expensive superfoods. Almost all fruits and veggies are packed with antioxidants. And finally, glycation, the gunk. This happens when excess sugar binds to proteins, lipids, or DNA and caramelizes them. This creates sticky compounds called AGEs that make tissues stiff and brittle. This internal cooking is the main biological cause of wrinkles and stiff joints. So how does the body repair this damage? That depends on your hormones, like insulin. Every time you eat, the insulin switch flips on. When insulin is high, you are in lockdown. The body focuses on storing energy, so the cleanup process is blocked. Not eating for a while makes insulin drop, allowing you to switch to autophagy, where your cells clean up by literally eating their own broken parts. So, why is the switch always stuck on? Normally it doesn't. Your body actually has a fuel gauge to tell you when to stop. But dopamine hijacks that gauge. It ignores the stop signals and makes you hunt for reward. And then, cortisol, the stress alarm. When you're stressed, your body thinks you're running from a predator. It literally melts down your muscle tissue to dump massive energy into your blood for a sprint. But you aren't sprinting. You are sitting in front of a laptop. So, you lose your muscle tone, and that unused sugar settles on your belly. Ancient biology is no match for modern food engineering. In nature, macros are almost always separated. You find sugar in fruit, but no fat, or fat in meat, but no sugar. But ultra-processed foods are different, industrially formulated to hit a mathematically perfect bliss point. This specific structure short-circuits the brain's stop signal, mimicking the rapid dopamine hit of a drug, rather than the slow satisfaction of a meal. To further engineerize it, they inject some sneaky substances. First, preservatives like sodium benzoate. Their job is to stop bacteria from multiplying to extend shelf life, but once eaten, they don't stop and keep suppressing bacteria, even the good ones. Then, emulsifiers like polysorbate 80. These are essentially industrial soaps. Remember the leaky gut we discussed? Emulsifiers are the detergent that scrubs away that protective mucus wall. So a simple rule is this: if a food didn't exist 200 years ago, try to avoid including it in your diet. Alright, enough theory. Let's see the strategy. Stop arguing about the roof when the foundation is cracking. Here is the logical hierarchy of how to actually fix the machine. Step 1. Cut the crap. Before you count a single calorie, you gotta cut out the noise. The goal is to eliminate the industrial formulations we just talked about. You don't need a PhD for this. Use the one ingredient rule. The best foods don't have ingredients. They are ingredients. Steak is just steak. Broccoli is just broccoli. If you simply eat foods that look like they came from nature, you automatically remove this BS. Step 2. Lock in the foundation. Once the junk is out, you need a new focus. Your goal is to shut down hunger and protect your muscle. Here's why this works. Protein is the most satiating nutrient, meaning it triggers the release of GLP-1, the same I'm full signal that modern weight loss drugs try to mimic. So don't count calories yet, count protein. Aim for a solid portion at every meal based on your body size. This way you physically won't have room for junk. Step 3. Adjust the energy dials. Now, let's talk about fuel. Protein is the foundation. It stays fixed. Carbs and fats are the dials you turn based on your lifestyle. Sit at a desk all day? Lower the carbs and rely on healthy fats for stable power. Train like an athlete. Turn up the carbs to fuel that performance. This ends the diet wars. Whether it's keto or paleo, they are just different ways of managing these energy dials. Pick the one you can actually stick to. Step 4. Fill the holes. Finally, the optimization. The word supplement literally means in addition to. It does not mean substitute. Why can't you just eat junk and pop a multivitamin? 2 reasons. First is bioavailability. Nature packages nutrients with the tools your body needs to absorb them. A pill is often just an isolated chemical. Absorption is poor. Second is purity, which is a big question mark. However, modern life does create gaps. We stay indoors and our soil is depleted. This is where supplements belong, as high-quality insurance to fix those specific holes. So the thing is, don't just blindly pop pills. Get blood work, identify your specific gap, then find a reputable brand to fill it. But if you skip step 1 and step 2, these pills are useless. And that's nutrition, pretty much all of it. At least the parts that actually matter. If you learned something, let the algorithm know. And if this hits 1,000 likes, I'll drop part 2. Also, comment the topic you want a full, dedicated video on. Okay, bye.